Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a decision tree model. Even before demonstrating how to build a decision tree model in SPSS, may I request you to subscribe to my channel, also like and share my videos. Let's begin by asking a simple question. What exactly is a decision tree model? I'd like to draw your attention to 6 important points when we speak of a decision tree model. First, a decision tree model is a supervised machine learning technique. Number 2, it is a rule-based approach towards model building. Number 3, it's a non-parametric approach towards machine learning. Number 4, a decision tree model requires less data cleaning. Number 5, a decision tree model is very simple and easy to use. Number 6, a decision tree model can handle mixed data type. With this background, let me proceed to introduce to you the data set that I will be working on. The data set that I'll be working on is called as the iris data set. As you can see here, it has 6 columns. The first column is ID. The second column represents the flower characteristics like sepal length. You also have sepal width. The next column here is petal length followed by petal width. I want to use these 4 variables, that is the flower characteristics like sepal length, sepal width, petal length, petal width as the independent variables. The last variable that I have is the species of flower. This is the variable which I will be using as the dependent variable. Remember, in a decision tree model, we need a dependent variable. Why? Simply because it is a supervised machine learning technique. Let's understand the first row here. The first row here represents a flower whose sepal length is 5.1 centimeters. Its sepal length is 3.5 centimeters. The petal length of this particular flower is 1.4. The petal width of this particular flower is 0.2 centimeters. This flower is Setosa species. What is the sample size of this particular data set? Let me go ahead to the last row. As you can see here, there are 150 rows in my data set. I'd like to also draw your attention to the species column. We would like to examine how many species of flower we have. Let me apply the filter. In the filter option, when I click on the drop-down menu, you can see here there are 3 species of flower. The first is Setosa. The second is versicolor. And the third one is virginica. So this is not a binary class problem. Remember, in a binary class problem, you have only 2 classes. Here, I have 3 classes, Setosa, versicolor, and virginica. Because I have more than 2 classes, this is called as a multi-class problem. This is important because a decision tree model is very good. It is extremely efficient in handling multi-class problems. With this background of the data set, let me now proceed to demonstrate how to build a decision tree model in SPSS. As you can see here, this is the interface of SPSS. It is blank because I have not loaded any file into SPSS. To load a file in SPSS, what you need to do is click on the File menu. This displays a variety of options. I'll be going to the recently used data. As you can see here, SPSS displays 10 recently used files. I'll be going right to the top. As you can see here, this is the iris file which I was recently working on. Let me select this particular option. The moment I select this particular option, you can see here, SPSS loads the file into the system. We are already familiar with some of the columns here: ID, sepal length, sepal width, petal width, and species. Without wasting too much time on the other details, I'd like to straight away go to the decision tree model. What is the path to execute a decision tree model in SPSS? As you can see here, there is what is called as the Analyze menu. Let me go ahead and click on the Analyze menu. You can see here at least 15 options that SPSS displays. The option that I am interested in is called as the Classify option. The moment I hover the mouse on top of the Classify option, SPSS displays all the items under the Classify option. The fifth option from the top, namely the tree option, is what I will select. Let me show you the navigation path once again. Please go to the Analyze menu, then Classify. After this, you can select the tree option. Once I select the tree option, you can see here, this is the decision tree dialog box. To the left side of the canvas, you can see what is called as the variables. Here, SPSS displays all the variables that are present in the data. The last of the options here is species. Let me select the species variable and push this into the dependent variables list. I have got some of the other variables like sepal length, sepal width, petal length, and petal width. I'm going to select all of these variables and push this into the independent variables. So this is how simple it is to run a decision tree model. All that you need to do is select a particular variable under the dependent list. The remaining variables can go into your independent variables list. I'd like to draw your attention to a very, very important option. That option is the growing method. You can see here, the default option is CHAID. What is CHAID? CHAID stands for chi-square automatic interaction detection. I'll be clicking on the drop-down menu. You can see here, there are three other options besides CHAID. One is what is called as exhaustive CHAID. The second one is what is called as CART. And the last option here is the quest model. CRT stands for classification and regression tree. The last option here is quest, which stands for quick, unbiased, estimated statistical tree. For the purpose of this video, I will be selecting the CART model or classification and regression tree. I'd like to draw your attention to three important points. First, a CART model produces binary splits. Number two, it can be used for both classification as well as regression problems. Number three, how does it select the input variable? There are two important statistics. One is what is called as the towing statistic, and the second one is what is called as the Guinness index or the towing criteria. With this selection, you can also choose any of the 5 tabs that are available at the top right-hand side. You can see here, you have the output tab, validation, criteria, save, and the options button. All of these things are not necessary. Depending on the requirements of the model, you can select those options which are relevant to your project. I like to select the output tab here. You can see here, the moment I select the output tab, you are getting the decision tree output options. There are 4 options at the top. The tree option, statistics, plots, and rules. I'll be selecting the statistics tab. Here, there's a very, very important option under the independent variables option. This option is called as importance to model. Why is this option important? This option is important because this gives me the predictor importance. It tells me what is the contribution of each and every independent variable to the model. The next thing that I'd like to select is the plots option. Let me go ahead and select the plots. Right at the top, you see what is called as independent variable importance to the model. I'll be selecting this particular option. Finally, you have another interesting feature which is called as rules. Let me go ahead and select rules. You can opt for generate classification rules. Here you have 3 different options. SPSS will generate the syntax as a syntax file, or you can also generate rules as per SQL. And the last option here is a simple text, in which case SPSS will produce the rules in a text file or a notepad. I repeat, SPSS will generate rules as a SPSS syntax file or as SQL or a simple text file. Once you choose this particular option, the next thing that you need to do is select export rules to a file. You can click on the option browse. Here in the desktop option, I will be creating a file name called as rules5. This is the name of a notepad file, and in this file you will be able to access all the rules of the decision tree model. With this, you can go ahead and hit the save button. I can now click on continue. The second option that you see from the top is validation. It is not mandatory that you do validation. However, if you are going to deploy the model in a real-time environment, you have several options here like cross-validation. This might take some time if you choose the cross-validation. The default number of folds is 10. Sometimes people also use a 5-fold cross-validation. The next option you have here is what is called as split sample validation, which will assign 50% of the cases to training. The balance 50% will be assigned to testing. For the purpose of this video, I will be ignoring both the cross-validation as well as split sample validation option. I will select this as none. Let me now proceed to hit the continue button. Once you have selected the validation criteria, the next option here is criteria. Let me select the option criteria. This will open up the criteria settings. You can see here, you can control the maximum tree depth. To the right-hand side, you can see minimum number of cases under the parent node as well as the child node. The default option is 100 for the parent node, and for the child node, it is 50. Since Iris dataset has a very small sample, I would like to reduce the number of cases in the parent node to 10 and the number of cases to child node to 5. There are other important options for cart. You can see here the impurity measure. The default impurity measure that the cart goes by, that the cart model goes by, is what is called as the Gini's measure. You can see here SPSS gives an explanation. It says the splits are found that maximize the homogeneity of the child nodes with respect to value of the target variable. As an alternative to Gini, you can also experiment with the towing statistic. I'll ignore the towing and go by the default option of Gini's coefficient. You can choose prune tree to avoid overfitting. Now, this is a typical problem with respect to any machine learning model. The problem is called as overfitting. To avoid overfitting, one of the strategies that data scientists apply is called as prune the tree. I will ignore this particular option and show you the next option, which is called as surrogates. These are optional things that you can select depending on the requirement of the project. Now, what are surrogates? Typically, you can see here, there is the automatic option that is chosen. The maximum number of surrogates would be one fewer than the number of independent variables, which is, since in the iris data set, I have got 4 independent variables, the maximum number of surrogates would be 4 minus 1, which is 3. Now, what is the benefit of choosing surrogates? Surrogates are used to classify the cases that have missing values on independent variables used in the tree. We can specify the maximum number of surrogates to compute for each split. Let me go ahead and hit the continue button. The last of the options here is what is called as save. Let me select the save button. This will produce the save dialog box. By default, SPSS gives you the option to save the following 3 variables. The first is terminal node number. You can also select the predicted value and predicted probabilities. If you want to export the tree model as an XML file, external markup language file, this option is also present. However, for the purpose of this video, I will ignore the option of exporting the tree model as XML. To keep it simple, I can also knock off this particular option of saving the terminal node number. With these selections, let me hit the continue button. There were quite a few selections that I made in the decision tree model. All of these things are not necessary. However, depending on the needs of the project, you can select some of these options. Once you have selected each of these variables, the last thing that you need to do is hit the OK button. In a span of seconds, you can see SPSS generates the output. You can see here in the left-hand side, this is the output of classification tree. There are different options. However, I'd like to draw your attention to what is called as independent variables importance. So this is a table which is called as independent variable importance. As the name itself suggests, it tells us which is the most important independent variable that helps me classify the species of flower. When you read the column heading, you can see independent variable. This is the first column. Then you have the importance. And lastly, you have the normalized importance. Along the row, you can see petal length, petal width, sepal length, and sepal width. The most important variable here is petal length, which has an importance of 61%, followed by petal width, which has an importance of 59%. The sepal characteristics are not that useful. The next important element which I'd like to show is the independent variable importance chart. You can see here, this is the independent variable importance chart. Along the horizontal axis, you can see normalized importance. You can also see here the importance of the variable. Petal length has an importance of roughly 60%. The same thing can be told about petal width, which is also important to the extent of 60%. When you look at sepal length and sepal width, it has an importance of 45% and roughly 23%. So these are the key drivers of the model. What is the inference that I can draw? Decision tree has classified the individual flowers based on the petal length and petal width. I'm interested to look at the tree diagram. Therefore, on the left-hand side, I'll be selecting the tree diagram. Let me go ahead and double click on the tree diagram. This opens up the tree editor window. I'm going to maximize the tree editor window. I can increase the zoom percentage to 200%. This is done only for visibility purpose. As you can see here, this is the topmost box. This box represents the species variable or the dependent variable. You can see here the breakdown of the three types of flower: setosa, versicolor, and virginica. SPSS gives you the distribution of each of these variables in terms of percentage as well as in terms of sample size. Below the dependent variable, you have the first important characteristic. The first important variable is petal length. If you travel towards the left side, it says 2.45. How do we read this? Simply put, when the petal length of a flower is less than 2.45 centimeters, decision tree predicts the flower to be setosa. So next time somebody gives you a flower and you look at the petal length of the flower, if the petal length of the flower is less than 2.45, you can straight away say that such a flower will be setosa. None of the flowers are versicolor or virginica. Now, this is an interesting question. What happens when the petal length is greater than 2.45 centimeters? It's not an easy decision to make. When the petal length is greater than 2.45, it is certainly not setosa. However, it could be any one of either versicolor or virginica. Let me scroll down. After petal length, I have to look at petal width. If the petal length is greater than 2.45 and the petal width is greater than 1.75 centimeters, all the flowers, I can't say all, but a majority of the flowers predict virginica. You can see here 97% of such flowers represent virginica. Barely 2% of the flowers predict versicolor. What happens when the petal width is less than 1.75 centimeters? When the petal width is less than 1.75 centimeters, majority of such flowers predict for versicolor. I'd like to draw your attention to a very important point here. When you look at this box, there is no other box below this. Since there is no other box below this, this box is called as the terminal node. However, when you look at this particular box, there is a node below this, and hence we will have to further dig and look at which is the next important criteria. Let me scroll down, and here you see petal length. Petal length less than 4.95 centimeters predict for versicolor flowers. On the other hand, when the petal length is bigger than 4.95 centimeters, it predicts for virginica. Majority of the flowers represent virginica. However, you have 34% of the flowers which predict for versicolor. Now, what is the risk of misclassifying a model? We have interpreted the tree diagram. This is the tree diagram. We have interpreted the tree diagram. One very important point that I'd like to observe, that I'd like my audience to note, is that CART model which we have chosen goes by a statistic which is called as the improvement statistic, and it creates binary splits. At the top, you have different options of displaying your tree diagram. Let me click on this particular option. You can see here within the box, you can see a bar chart. There are other options as well, which allows you to customize the look of the decision tree. You can see here, there are three important options. The default option is top-down. However, you can also change this to a different option. Upon clicking on the second button, the orientation will be from left to right. There's a third option here, which represents orientation from right to left. I'll go back to the original orientation, which is top-down. Let me close the decision tree diagram. I'd like to look at the risk statistic. What is the risk statistic? With any machine learning model, it becomes important to study the risk estimate. What is the risk of misclassifying a flower? Here, the risk estimate that I'm getting is 0.027 and the standard error of 0.013. Since the risk value is 2%, it means that this model is approximately 98% correct, which is a very good number. The next table that I'd like to draw your attention to is what is called as the confusion matrix. At the top, you can see the predicted values. There are three columns here: setosa, versicolor, and virginica. And along the row, you can see setosa, versicolor, and virginica again. The last column is percentage correct. You can observe here, almost all of the setosa flowers are correctly classified. Therefore, you're getting the percentage of correct classification as 100%. When it comes to the second flower, namely versicolor, the percentage of correct classification is 94%. When it comes to virginica, the percentage of correct classification is 98%. The overall accuracy of the model is 97.3%. You have 9 different numbers here. How do you read these numbers? The thumb rule here is the diagonal elements represent the correct classification and the off-diagonal elements represent the misclassification. So numbers 50, 47, and 49 represent the correct classification of the model. So what we have seen here is a detailed look at the output produced by the decision tree model. We have looked at the tree diagram, the risk estimate, the confusion matrix, the independent variable importance table, also the independent variable importance chart. The last two things which are remaining would be the predicted value. Let me go ahead and minimize the output window. You can see here, this is the original data entry. My apologies. This is the original data editor window I had. SPSS has created several columns. You can see here, this is the predicted value. The first few flowers, this is the dependent variable, and this is the predicted value. Predicted by whom? Predicted by the cart model. When the actual and the predicted match, that represents the correct classification. The first few cases are matching, implying that the actual and the predicted cases are setosa, and therefore I can go ahead and say that the first 7 are correct classification. You can see here, majority of the cases are matching. Let me draw your attention to the 71st case. This is a misclassification. Please observe that the actual species is versicolor, but the model predicted value is virginica. Like this, you can go on to inspect individual cases when the sample size of your data is small. SPSS also creates 3 additional columns. You can see here, this is the predicted probability for species, namely setosa, that is the first flower. This is the predicted probability for the second species of flower, and this is the predicted probability for the third species of flower. As you can see here, when you add up the 3 numbers, it will sum up to 100%. For the first flower, the predicted probability is 1. What does this imply? This simply implies that the first record is predicted as setosa with 100% probability. Now, I know that this is a very small data set. For a large data set, you will definitely not be getting such optimistic numbers. When you scroll down, you can see here, there are some of the flowers which are predicted as versicolor. SPSS also displays different numbers in the second column. You can see here, this is the propensity or probability that the flower would belong to virginica. If you look at the 71st case, SPSS has predicted this particular flower as virginica. Why? Simply because there is a 0% chance that this particular flower is setosa, 2% chance that this is versicolor, and 98% chance that this flower is virginica. Out of the 3 numbers that you see here, 98% is the highest, and therefore SPSS predicts this particular flower as virginica. So this becomes very, very important, especially if you are looking to deploy a model. The last step of the analysis is to look at the rules. You can see here, I have created the rules for the different species of flower. Let me go ahead and double click on this particular notepad. You can see here, SPSS generates the rules for each and every node. What you're seeing here, let me repeat this. What you're seeing here is the rule for each and every node. This represents node 1. It's a very simple if-then condition. If certain characteristics are satisfied, like petal length is not missing and petal length is less than 2.45, so on and so forth, what does SPSS predict? It predicts that such a flower is setosa. What is the probability associated with this? There is a 100% probability associated with node 1. Similarly, you can see here, this is node 5. These are the rules that predict for node 5. You can also see the characteristics or the prediction for node 5. Node 5 mainly predicts for versicolor. Similarly, you have node 6 and node 4. What you can do is you can copy these rules into SQL, and for future predictions, all that you need to do is select the rules and hit the run button. It will be able to generate predictions for future cases. With this, I have come to the end of today's video. In today's video, we've looked at a very, very powerful decision tree model, namely the cart model. We have also seen what is a decision tree, the different types of decision tree, and how to build a decision tree model in SPSS. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again. Have a great day ahead.